Hello. In this video, I am going to show you how to do stoichiometry problems. Stoichiometry is really a fancy word that we use for those problems where we calculate unknown amounts of a reactant or product, starting with known amounts of another reactant or product. I will show you two different types of problems. One is the easiest kind, and then one that is a little more involved. And I will also show you two different ways of doing these kinds of problems. One is the traditional method that is used all over the world, and the other is called the magic number method, and it's a simpler way of looking at these problems. You can decide which one makes more sense to you and which one you like best. And once you get it down, stick with it. It doesn't really matter, you will get the same answer. Let's look at a practical example. I have a chemical reaction here, and the question says, how many moles of sodium azide, this compound here, are needed to produce 2.97 moles of nitrogen gas, which is enough to inflate an airbag. Now you can imagine that if I have too much sodium azide, I will produce more nitrogen gas, and that will cause that airbag to burst, and it's going to defeat the purpose. I will not get much of much protection in an accident if the airbag bursts open instead of inflating and deflating like it's supposed to. So I know the amount of nitrogen that I need to be able to inflate the airbag correctly, and now I can back calculate to figure out how much sodium azide will I need to produce that much nitrogen. I will show you a little little diagram that involves all the steps that are needed in a particular stoichiometry problem. Now, you may or may not use all of those steps. These are all the possible steps, but you may not use them all. It just depends on what the problem is asking. Here's what the steps look like. Grams of a compound A, I can convert those to moles of compound A, of the same compound, then convert from moles of A to moles of a different compound, compound B. Then I can convert moles of B to grams of B. Now, like I said, these are 3 steps, and these are the most steps that you will use in a stoichiometry problem. You don't have to use them all. For example, in this problem, it asks me how many moles of B are needed to make 2.97 moles of A. So I'm right here. I don't need to mess with grams because I'm given an amount of moles of A and I'm asked an amount of moles of B. So I don't need to mess with either grams of A or grams of B. But in other problems, you might have to. So these are all the possible steps that you can have when doing stoichiometry problems. Let's take a look at how we solve this one then. When I convert from moles of one compound to moles of another compound, like I'm being asked to do here, I need to use the molar coefficients from the balanced chemical equation. You have to start with the balanced chemical equation. And that's the first step in any stoichiometry problem. This equation is already balanced, so I don't have to spend time doing that. But make sure that you spend, 30 seconds or so checking to see if your equation is balanced. Then once you balance it, you can see that these numbers in front of each molecule, these are called coefficients, molar coefficients, and that's because they give me molar amounts for each molecule. So I can read this as 2 moles of sodium azide can decompose to give me 3 moles of nitrogen gas and 2 moles of sodium solid. So these give me amounts of moles. And then I can relate moles of one compound to moles of another. Think of this is an arrow, but you can think of it as a equation, really, where you relate moles of one to moles of the other. So let's solve this problem. Always start with the amount that you are given in the problem. Never start with molar coefficients or the molar masses. So I'm given 2.97 moles of nitrogen, and I start with that. So I write 2.97 moles of nitrogen multiplied by, now I can write the molar coefficients as a fraction. This becomes my conversion factor. I know that for every 2 moles of sodium azide, I get 3 moles of nitrogen gas. I want to write the moles of nitrogen at the bottom because that way I am multiplying and dividing by the same unit, which means that I can actually cancel these out. Then all I have left is the moles of sodium azide at the top, which is what I really need. So I can write 2.97 moles of nitrogen multiplied by 2 moles of sodium azide divided by 3 moles of nitrogen gas. The moles of nitrogen will cancel out, and if I do this calculation, 2.97 times 2 over 3 gives me 1.98 moles of sodium azide. That's what I've got left as a unit. So now I calculated how many moles of sodium azide I need to start with to be able to produce this many moles of nitrogen. As I said, this is the simplest type of problem where I have moles of one compound and I relate it to moles of another compound. But what if I start with an amount of grams, not moles? How do I go about that? Well, let's take a look. How many grams of sodium azide are needed to produce 50 grams of nitrogen gas? So in this case, I don't have an amount of moles anymore, I have grams, and I'm being asked to figure out an amount of grams. So I am here, I got grams of A, and I'm asked to calculate grams of B. I cannot go from grams of A to grams of B directly. I cannot even go from grams of A to moles of B directly because I have no way of relating grams of one compound to moles of another compound. The only way I can relate one compound to another is by using the molar coefficients. So moles of one compound to moles of another in the chemical equation. So the first thing that I need to do is take that amount of grams and convert it into moles. And I do that by using the molar mass of A. I cannot use the molar mass of B because that's a different compound. I can only use molar mass of B when I'm going from grams of B to moles of B or moles of B to grams of B. To go from grams of A to moles of A, I have to use the molar mass of A. In this case, my compound A is nitrogen, gas. So I have grams of nitrogen and I need to convert to moles of nitrogen. And I use the molar mass of nitrogen to do that. Once I have the amount of moles of nitrogen to convert to moles of sodium azide, which is my other compound, I can use the molar coefficients from the chemical equation like we did in the previous problem. And once I have moles of sodium azide, I can go to grams of sodium azide by using the molar mass of B or molar mass of sodium azide. Note that these are two different compounds, and so I have to use two different molar masses, but the steps are the same. If I'm going from grams to moles, I have to use the molar mass, or moles to grams, I have to use the molar mass. I just use two different molar masses because I have two different compounds. So let's take a look at how we do this. Here's the steps again. And I start with the amount that I'm given in the problem, which is 50 grams of nitrogen gas. 50 grams of nitrogen gas. Now I use the molar mass, so if you figure out the molar mass of nitrogen is about 28.01 grams. So I know that every mole of nitrogen weighs 28.1 grams, but I have 50 grams. So I write grams of nitrogen, 28.01 grams of nitrogen at the bottom and 1 mole at the top. My grams of nitrogen will cancel, leaving me with 50 times 1 mole of nitrogen divided by 28.01, and I get approximately 1.8 moles of nitrogen. So I went from here to here. I went from grams, and now I have moles of nitrogen. Now to go from moles, so I went from grams of A here to moles of A. So I'm right here. And now I need to relate moles of A to moles of B. So I start, once again, I have another equation here, but I start with the amount that I'm given, or I calculated, which is 1.8 moles. Okay, so 1.8 moles of nitrogen. And now I can go up here. Remember when I'm going from moles of one compound to moles of another, moles of A to moles of B, I have to use the balanced chemical equation. And just like we did for the other problem, I have moles of azide on top because that's what I want to end up with, and moles of nitrogen at the bottom because I want them to cancel. I've got moles of nitrogen up here that's being multiplied, and then I put moles of nitrogen at the bottom so they can cancel out. I get 1.8 times 2 moles of sodium azide over 3. And this gives me approximately 1.2 moles of sodium azide. I am here now, so I did 2 steps, this one, and now I'm here. To go from moles of sodium azide to grams of sodium azide, I have to use the molar mass again, not the molar coefficients, but the molar mass. But in this case, I have to use the molar mass of sodium azide, not nitrogen, because it's a different compound. So let's once again start with 1.2 moles of sodium azide because that's the amount that I'm given here. And I want to get to grams of sodium azide. So I know that every mole of sodium azide weighs approximately 65.01 grams. 1.2 moles of sodium azide multiplied by 65.01 grams of sodium azide over 1 mole of sodium azide. So I'm multiplying moles of sodium azide and dividing by moles of sodium azide. So this unit will cancel out, leaving me with 1.2 times 65.1 grams of sodium azide over 1. And that gives me approximately 77 grams. So I have moles of B, and I'm going to grams of B by using the molar mass here. Note that if you're starting with an amount of grams, you divide by the molar mass, gram per mole, to get to moles. But if you're starting with an amount of moles, you multiply by the molar mass to get an amount in grams. This is the traditional method. Let's now take a look at the magic number method. Let's do the same problem so that we can compare it. Here's the same problem. How many grams of sodium azide are needed to produce 50 grams of nitrogen? The first thing you need to do is multiply every compound in the balanced chemical reaction by X. Okay, or Y, or whatever number or letter that you want, right? This is your unknown. So multiply by X, and it becomes 2 times X sodium azide going to 3 times X nitrogen plus 2 times X sodium. Okay? The next thing that we have to do is multiply each compound by its own molecular mass. So I have molar mass of sodium azide, approximately 65, so it becomes 65 times 2 times X sodium azide. The molar mass of nitrogen is about 28, so 28 times 3 times X nitrogen, plus the molar mass of sodium is 23. So 23 times 2 times X sodium. Once you are done with that, you figure out which amount you are actually given in the problem and of what compound. So in this problem, I'm given 50 grams of nitrogen gas. So I go up here to the nitrogen and I look at this product here and I set this product equal to the amount that I'm given in the problem. So I have 28 times 3 times X, 28 times 3 times X, and I set that equal to the amount of grams of nitrogen that I'm given. So it's equal to 50. Then I multiply, so 28 times 3 gives me 84. I still have it multiplied by X, so 84 times X still gives me 50. I just multiplied this, reduced this. And now I can find X by dividing 50 by 84. So X is equal to 50 divided by 84, and it comes out to be about 0.595 or approximately 0.6. This is called your magic number, and I can take this X, this value here, plug it in for the X in any of these compounds and figure out the amount of grams of all of them. So let's do the amount of sodium azide like we did in the previous problem. So I take the product that's in front of sodium azide, 65 times 2 times X, and I substitute X for this magic number here, 0.6. So that it becomes 65 times 2 times 0.6. And if you do that product, you come up with 77.4 or approximately 77 grams of sodium azide, which is exactly what we came up with here with doing the other method, the traditional method. So I can do the same for the amount of sodium or any compound in the balanced chemical reaction. I can take the product that's in front of sodium, which is 23 times 2 times X, and replace X by 0.6, which I calculated, and I get 23 times 2 times 0.6, and I get 27.6 grams, or approximately 28 grams, to the correct significant digits. Note that this magic number, this number here, the X, is unique to this particular problem. If I change the amount of grams, this X will change. If I change the balanced chemical equation, this X will change. So it's unique to that particular problem. But once you calculate it, you can use it to figure out amounts of anything within that problem that you have. Now, I don't necessarily have to end up with grams of sodium azide. I can also just calculate amount of moles for these other compounds. And if I just need to figure out how many moles of sodium azide are needed to produce 50 grams of nitrogen gas, I don't need to multiply by the molar mass necessarily. I can just write 2. So for sodium azide here, I have 2 times X, and my X is still 0.6. So 2 times 0.6 gives me 1.2 moles of sodium azide, and that's what I can just stop there. That I don't need to multiply by 65, which will give me the amount of grams. In this case, I can just stop at 1.2 moles. I can do the same with sodium. It's 2 times X, so 2 times 0.6 would still give me the same amount of moles of sodium. So it will be 1.2 moles of sodium as well. But I can use this magic number then, this number here, to calculate amounts in grams like I did here, or amount of moles like I did here. Just for the moles, remember that you don't need to multiply by the molar mass. You can just substitute the X by that in the product by using just the molar coefficient. So 2 times x in this case without the 65 is equal to 2 times 0.6, which is the value for x from the previous slide, and I get 1.2 moles. Okay, I hope that this has been helpful to you. If you have any questions, please feel free to ask them in class.